Hi everyone, I hope you're all good. So today I'm going to be looking at this question that is based on probability as well. So this is our third video that is based on probability, particularly the question in which we can use a tree diagram to help us answer these particular questions. So we have question 10 here, which reads as follows. It says that a bag contains a certain number of tennis balls that are the same in all respect except color. Now, it is further given that there are 5 green balls and the rest are blue. So we know that we have 5 green balls and the rest are blue. Right, it says that Nomi picks a ball, observes the color, and does not put it back inside the bag. So does not put it back in the bag. We know that this is a case of without a replacement. Right. So and then it is further given that he picks a second ball. Then we know that this happens for the second time. He picks the ball and observes the color. The probability that both balls that Nomi picks are green is 5 over 18. Now, what does this actually tell us? It tells us that the first ball was green and the second ball was also green. So this is the probability that is associated with that particular outcome of green, then green. So now we can just use a tree diagram for illustration purposes. So we can just say here, we know that we have, it's either we can select a blue ball or we can select a red ball. But then let's just do this. It's either we can select a blue ball or we can select a green ball. Then there is a probability that the first ball is blue, then the second ball can also be blue, or the second ball can be what? Can be green. And then now let's have a look at another case that we can have. Let's say we have this case here whereby the first ball was green, then the second ball was blue, or the first ball was green, then the second ball was green as well. So we have green and green. Which is the outcome that we are more interested in? Because this outcome is blue, then blue, blue, then green. This is green, then blue, and then this is green, then green again. So this is the outcome that we are more interested in. So remember what is needed of us here to determine the total number of balls. So what we can do with this particular question here, we can just write, we are going to let x equals what? Total number of balls, right? So now if we let x represent the total number of balls, so how many balls are we having? We have 5 green balls at first. So we know that the probability of selecting a green ball, this is what? This is 5 over x, right? So 5 over x. So since we know that the probability of first selecting a green ball is 5 over x, then what would it be the probability of selecting a green ball as the second ball if the green ball was the first ball that we selected? This was going to be 4 over x minus 1. Then why 4 over x minus 1? Because remember we have one less balls in total. And then remember again, what did we have here? We had 5 balls. We observed that the first ball here was green, and then we never replaced that same ball inside the bag, and then it means that we are only now left with 4 balls inside the bag. So we have 4 over x minus 1. Then remember, how do we get the probability that is associated with this outcome here? Since we are going to be going across, remember we are going across, so this is green, then green. Then it means that we are going to multiply those two probabilities. So we are going to multiply 5 over x multiplied by 4 over x minus 1. Then this is going to give us the probability of selecting green, then green as the second ball again. And then now, when we now continue to find the next part here, remember we were told that the probability of selecting a green, then a green was what? Was 5 over 18, which would have been obtained this way. So it means that also this portion here, or this part here, is also equals to 5 over 18. And then in this case, we know that we are going to have 5 times 4, 5 times 4, this is going to be 20 over, and then this is what we have here. So since this is what we have, and then we have x times x minus 1, we are going to have x squared minus x, which is equals to 5 over 18. So this is what we have now. So what are we going to do? We know normally what we can do here, we can just cross multiply. So we are going to have 20 times 18, we know that we are going to get 360. This is 360. And then 5 times x squared minus x, this is going to be 5x squared. Then 5 times that negative x again, that is going to give us negative 5x. So this is what we have here. So what can we do in order to solve for x here? We know that we can just write this in standard form. In standard form, we can have 5x squared minus 5x, and then minus 360, and then which is equals to 0. And then looking at these numbers here, looking at the value of a, b, and c, we can see that we have a common factor here. We have a common factor here, which is 5. So you can just divide each and everything here that is on this equation by 5, so that we are going to be left with x squared, and then x, and then minus 72. And then now we are going to be left with 0, because 0 divided by 5, this is going to be 0. Then now from here, we know that this we can factorize. So how can we actually factorize this? Remember that this can be factorized as x minus 9 and x plus 8, which is equals to 0. So this is what we have here. Then how do we deal with this? Remember, we know that this is either x is equals to 9 or x is equals to negative 8. So, but then remember, since we said that x is the total number of balls, we can't expect to have, we don't actually expect to have what? A negative number, because we can't have a total of something that is equals to a negative number. So we are going to reject that. We are going to reject this. We are going to reject this, and then we are going to say, therefore, x is equals to 9. X, which is what? The total number of balls. So this is how we actually try and solve this particular question here.